everyone. I hope that you have been having an interesting and fascinating time with the amazing cohort that we have. I am super excited to be here with NanoSoils, the founder of NanoSoils, Kong Vu. Can we just get the slides up? That would be awesome. Thank you. We'll just start. Kong, thank you. Kong, you have come to Australia. You came to Australia in 2017. Can you tell me what brought you to Australia?
So hello everyone, my name is Kong, so from Vietnam. So before that, I got a full scholarship to study in South Korea, and I studied biomedical engineering. And then I came to Australia to study biomedical engineering.
A full scholarship to bioengineering in Korea, and then you came here to study medical technology.
Yes, because my childhood dream is to have cure cancer.
You wanted to cure cancer?
Yes.
That's a minor achievement, isn't it? So what was your first experience in Australia?
Yes, so a year after my very first time experienced bushfires, like at that time I stayed in my room with the air conditioner on and watching my plant outside dying. And it made me thinking, what should we do? Because if all of the plant die, we have nothing to eat. And I did some research and found that the research I work in cancer can actually help for the plant, help the plant deal with drought stress and heat wave.
So I don't know about you guys, but when I'm in the bushfires, I was not in my room thinking about how can I potentially solve a massive problem of plants dying. So amazing, you decided to see if you can use your nanotechnology. So can you tell me a little bit about the experiment that you ran?
Yes, so I have the nanoparticle in the lab, and so I buy some seed and I mix them together. At first, I didn't know how to sow the seed properly, but after a few trials, I come to realize like one of our nanoparticle can help the root of the plant grow stronger. So this is one of the fundamental things to help the plant survive under drought stress and heat wave.
Amazing. So the roots got very long based on your initial coating of the seeds. And so I don't know about you guys, but I actually don't know what a nanoparticle is. So can you tell me a little bit about a nanoparticle and what it does to the plants?
Yes, so it's like something tiny particles, like 1,000 times smaller than human hair.
1,000 times smaller than human hair.
Yes,
That's super small.
Yes, and then the materials I'm using is silica. So silica is very basic and it's the second most abundant materials. And what we are doing uniquely is we chemically make the silica nanoparticle that can be absorbed by the plant. And when the plant gets the nanoparticle, it can trigger the plant for this hormone, and this hormone make the root grow stronger. So that's help the plant get more water in the soil, so help the plant survive under drought.
So nanoparticle works the same way that cancer technology works?
So we use the same nanoparticle from cancer, but to apply for agriculture, we optimize the formulation and to make it more sustainable and economically.
Amazing. And it triggers the hormone in the nanotechnology. Hormones, it triggers something within the plant that helps it grow deeper roots.
Yes.
So, so you focused an experiment on drought. So tell me a little bit about that experiment.
Yes, so first I need to have to validate that the nanoparticle really work for agriculture. So I did a very extreme experiment. So I got the seed and the nanoparticle and I saw in the soil for 7 days without any watering them. And we figured out that the plant with the nanoparticle just die, and with nanoparticle the plant can survive and develop into the baby plant.
I don't know about you guys, but that's, an extreme experiment of 7 days of watering a seed to start off with, no water whatsoever, and your seeds were the ones that actually were successful and survived. That's quite amazing. And you won an award for this, correct?
Oh yes, so with that concept, so I won the Sun and Innovation Award sponsored by CIDC. And the award comes with cash to help me expand the trial.
You're not going to spend it on anything but on further trials, obviously, because, okay, so we've solved the drought problem, people, okay? You ready for this? So you didn't want to just stop on the drought. You wanted to continue doing other things. What did you decide to do?
Yes, so because originally we used nanoparticles to deliver anti-cancer drug, and we realized anti-cancer drug and pesticides are pretty much similar. So if we can successfully deliver anti-cancer drugs, so why don't we use for pesticide delivery? So in this case, we use the same nanoparticle platform for drought stress, and we add more one function is for pesticide delivery. So which means we solve the problem that the pesticide spray strip or pesticide residues, and it's good for farmers and for environment as well.
So you wanted a 2-for-1, basically. You wanted
Yes.
to be able to solve the aspect of drought, but you also wanted to solve the aspect of pesticide. So so what did you do next?
So next, I explore the agrochemical market. So I start with fungicide. So we make the silica nanofungicide, and I talk to agrochemical industry. And the lesson I learned is this is something nice to have, but not really something they want, simply because they have better options, chemical fungicides and genetics modification tool. And some people even say nanotechnology is so fancy and expensive for agriculture.
Well, nanotechnology is super fancy, but maybe not necessarily for agriculture.
Yeah.
So it didn't work for fungicide. The market was not thought that there was already existing solutions. So what did you do next?
Yes, so I took a few steps back and think what is the most challenging for agrochemical industry, and I figured out that insecticides is the one, because insecticides is developed to protect the crop from the pest, but at the same time, insecticides kill the bees. Bee is essential, and we have to protect the bees. And this is the right place for nanotechnology, because here we make the nanoparticle and deliver to the plant, protect the plant, at the same time minimize the insecticide residues. It's good for environment and for agrochemical industry as well.
And so obviously we don't kill bees because, as we know, we're in an ag and food tech place and we want to have bees to make sure that that happens. Was there a specific crop that you decided to focus on?
Yes, so we focus on cotton.
On cotton. And why? What specifically do you want to do in cotton?
Yes, because Australia is one of the largest cotton exporter, and cotton consumes a lot of water and insecticides. So cotton ticks on the box for the nanotechnology here.
Amazing. So cotton is one of the most important things that you wanted to focus on to see how you can potentially validate it. So where are you now with the development of the product?
So we have the nanoparticle ready, and we have validated the proof of concept. So we are running the trial in the glass house now.
In a glass house right
Yes.
now? Yeah, okay. And what is the dream?
So our dream is to have cotton growers save at least 5% of water and reduce at least 10% of pesticide residues to environment, to have farmer adopt a net zero plan.
5% reduction of water and 10% of reduction of pesticides. Now, I don't know about you, but I actually looked it up this morning, because 5%, when we're going through it, we're like, okay, 5% doesn't sound like a lot, but really, when you start calculating the cost of this, I looked it up this morning. Thank you, Andrew. The value over the past 5 years of water prices, they varied from a long-term average from $190 per megaliter to $1,000 per megaliter, as some of you in the audience would probably know. So that would be a savings per hectare between $60 to $300, which is quite significant. So who are you working with?
So we have the support from two major universities, with Professor Justin Gooding from the University of New South Wales, who expertise in nanotechnology, and with Professor Pratt from Western Sydney University, who expertise in plant and soil.
So you have nanotechnology, you have plant and soil, you have your genius mind, and you have someone with finance. Amazing, and two very well-established universities. What is next for you?
So because the technology here is scalable, so which means once we succeed in one drop, we can move to another. So the next one that we are also running the trial in the glass house at the moment is pasture and wheat.
Pasture and wheat. All right, so once you've solved cotton, you're going to move on to pasture and wheat. Amazing. So what do you need in order to make your dream come true?
So we are looking for a partnership with research organization to help us expand the trial, and at the same time, we are looking for investment to scale up the nanotechnology.
Amazing. Please make sure that you scan the QR code to follow his journey, and if you're interested, come and see Kong later on. Thank you so much.
Thank you.